What if the single most critical factor in your child's future brain development isn't genetic, but is actually determined by the angle of the sun during your winter pregnancy?
Yeah, that's a wild thought, right?
It really is. I mean, welcome to today's deep dive. Our mission today is to basically tear down the myth of the sunshine vitamin.
Which is long overdue, honestly.
Completely. We are looking at this highly revealing stack of sources. There's a comprehensive clinical brief from the Berkeley Center for Reproductive Wellness. And alongside that, we've got some heavily peer-reviewed medical studies from journals like JAMA Pediatrics and Human Reproduction.
And the data in there is just undeniable.
Right. And what they reveal is that the substance we just casually call vitamin D is not some some minor nutritional accessory. It is a hidden architect.
Exactly.
So we are going to explore how this molecule operates as a master controller of fertility, pregnancy, and, well, fetal neurodevelopment.
The term vitamin is actually, it's a historical misnomer that severely downplays what we're even dealing with here.
So.
Well, a vitamin is an essential nutrient you have to get through your diet
Right.
because your body can't synthesize it. But this molecule is a potent, endogenously produced steroid hormone.
A steroid hormone? Wait, so it's not like vitamin C or something?
Not at all. I mean, it regulates over 2,000 different genes in the human genome.
Wow. 2,000.
Yeah. When we look at the clinical data regarding human reproduction, we're looking at a systemic hormone that essentially dictates the viability and creation of human life.
Which makes the standard medical approach to this seem almost, comical when you actually look at the numbers.
It really does.
Because if you examine many of the standard prenatal vitamins on the market right now, they typically provide about, 400 to 600 IU of vitamin D?
Right, which is just a drop in the bucket.
Exactly. Based on the medical studies in our stack, relying on a 400 IU dose for optimal reproductive health is like bringing a squirt gun to a house fire.
That's the perfect way to put it.
I mean, the biological demand your body has for this hormone during reproduction just vastly outpaces that baseline.
The physiological math simply doesn't add up. To understand why that squirt gun approach fails, we really have to look at how this hormone is actually synthesized and utilized by the body.
Okay, lay it out for us.
So, in its natural state, UVB radiation from the sun hits the skin and interacts with a protein called 7-dehydrocholesterol.
Okay.
And that interaction converts the protein into pre-vitamin D3. Then your liver steps in to metabolize it, and finally, your kidneys convert it into its active, usable hormonal form.
Which is called calcitriol, right?
Exactly, calcitriol. And once it's active, it travels through the bloodstream, managing immune function, controlling systemic inflammation, and directing cellular growth.
Okay, let's unpack this. Because if our bodies are fundamentally designed to manufacture this crucial hormone from sunlight, to keep our reproductive and immune systems functioning, then we're basically living in a massive self-imposed evolutionary mismatch.
100%.
Our biology expects us to be outside, near the equator, absorbing UVB rays. And instead, we trade the outdoors for sitting under fluorescent lights in office cubicles.
Yeah, the structural deficiency we see today is basically inevitable. What's fascinating here is how multiple variables compound that evolutionary mismatch.
Right. Like what?
Well, the shift to an indoor lifestyle is the foundational problem, sure, but geography acts as a massive multiplier. The brief from the Berkeley Center highlights residents of northern latitudes. They specifically cite places like New York City as high-risk populations.
Oh, because of the winters.
Exactly. During the winter months in these latitudes, the sun sits at such a low angle in the sky that the atmosphere actually absorbs the vast majority of the UVB rays.
So even if you decided to, brave the freezing cold and stand outside in Central Park in January in a t-shirt, your skin wouldn't synthesize the hormone.
Right, because the specific wavelength of light isn't penetrating the atmosphere at all. The physiological trigger is entirely absent.
That is wild.
And skin pigmentation adds another highly complex layer to this, too.
Oh, because of melanin.
Yes. Melanin is an evolutionary marvel, right? It acts as a natural sunblock, absorbing UV radiation to protect the skin from DNA damage and skin cancer.
Right.
But because it is so efficient at blocking those UV rays, it also significantly blunts the conversion of that 7-dehydrocholesterol.
Ah, I see. So it's a double-edged sword.
Exactly. An individual with darker skin requires vastly more time in the sun to synthesize the same baseline amount of the hormone as someone with a lighter skin tone.
Wow. Okay.
And then you factor in dietary restrictions like vegetarians and vegans who bypass the few natural animal sources of the vitamin. And the result is just this rampant population-wide deficiency.
Which means millions of people are essentially walking around running on an empty tank, specifically regarding their reproductive health.
That's exactly what the data shows.
And the sources make it very clear that if you are listening to this, you shouldn't just guess where your levels are.
No, absolutely not. Guessing doesn't work.
Right. The standard biomarker to ask your doctor for is the 25-hydroxyvitamin D, a blood test, or 25-OHD, and the clinical threshold we're aiming for is at least 30 nanograms per milliliter.
Yeah, and I want to emphasize that the 30 nanograms per milliliter mark, or 75 nanomoles per liter, depending on the units your lab uses, that is the absolute floor.
Just the floor, not even the optimal level.
Right. Below that, your body begins rationing the hormone. It prioritizes immediate survival functions over secondary systems.
And biologically speaking, reproduction is considered a secondary system, isn't it?
Exactly. If you are deficient, the body just dials down its reproductive efficiency. It says, we don't have the resources for this right now.
And that takes us directly into the reproductive organs themselves. Because when researchers look at the female reproductive system on a microscopic level, they don't just see some nutrient floating around.
No, they see customized infrastructure.
Right. The ovaries, the uterus, the fallopian tubes, and the eggs themselves, they all contain vitamin D receptors, or VDRs.
Which is huge.
I like to think of these receptors as dedicated cellular docking stations. They are built exactly for this hormone, just sitting there, waiting for the right key to turn the lock.
And the mechanism that occurs when that key turns is quite remarkable. Once the hormone binds to those cellular docking stations, it enters the nucleus of the cell and binds directly to the DNA.
Wait, it goes straight to the DNA?
Yes. It acts as a transcription factor, meaning it literally turns specific genes on or off.
That's incredible.
In the ovaries, it activates genes responsible for producing aromatase, which is an enzyme crucial for estrogen production and healthy egg maturation.
Okay, so it's setting the stage.
Exactly. And in the uterus, it upregulates genes like HOXA10, which thickens the endometrial lining and makes it receptive for an embryo to implant.
That perfectly explains the dramatic shift in clinical outcomes mentioned in that Human Reproduction Journal study.
Oh, absolutely.
Because if those docking stations remain empty, the genes aren't activated, the lining doesn't thicken properly, and the whole machinery misfires.
Right, the body just isn't prepped for it.
But when women hit that 30 nanograms per milliliter threshold, they see significantly higher clinical pregnancy and live birth rates, whether they are conceiving naturally or undergoing IVF.
And the IVF data is particularly striking because it controls for so many other variables. It really allows us to see the hormone's isolated impact on implantation success.
That makes total sense.
We also see this regulatory power profoundly demonstrated in patients with polycystic ovary syndrome, or PCOS.
Right, because PCOS is characterized by severe hormonal disruptions.
Exactly. Particularly elevated androgens like testosterone and systemic insulin resistance.
And since we know vitamin D works as a genetic regulator, it's not just like masking those PCOS symptoms, it's literally getting under the hood to recalibrate the whole environment.
It acts on multiple fronts for PCOS. The active hormone improves the sensitivity of insulin receptors throughout the body.
Okay.
By reducing insulin resistance, it lowers the compensatory hyperinsulinemia that typically drives the ovaries to overproduce those androgens in the first place.
Ah, so it stops the cycle at the source.
Exactly. The clinical trials show that when targeted vitamin D supplementation is introduced, it directly correlates with a reduction in testosterone levels, resumption of regular ovulation, and much higher pregnancy success rates.
That is massive for anyone struggling with PCOS.
It really is.
Yeah.
And by stabilizing the endocrine environment, it also mitigates the risk of early miscarriage, securing the pregnancy in those highly vulnerable first trimester weeks.
Okay, so once that implantation is secure, the entire biological paradigm shifts.
Yeah.
We basically move from the setup phase into active construction.
Yeah, that's a good way to put it.
The demand for this hormone doesn't just increase, it skyrockets because it now has to serve as a vital shield for the mother's health.
The physiological stress placed on the maternal body during this phase is immense. Let's just look at bone mineral density for a second.
Okay.
The mother must supply an enormous amount of calcium to mineralize the developing fetal skeleton. But human intestines are inherently inefficient at absorbing calcium from food.
Really?
Yeah. Without the active form of vitamin D, the vast majority of dietary calcium simply passes right through the digestive tract unabsorbed.
I picture it like a highway system with all the toll booths closed.
Exactly.
Like, You can eat all the calcium-rich foods you want, but if the hormone isn't there to open the cellular toll booths in the intestinal lining, the calcium just bypasses the bloodstream entirely.
That is precisely the mechanism. The hormone stimulates the production of calcium-binding proteins in the gut, throwing those toll booths wide open.
Wow.
But here's the scary part. If the mother is deficient, her body still has to meet the fetal demand. So it triggers a hormone called parathyroid hormone.
Okay, what does that do?
It acts as a biological wrecking ball. It leaches calcium directly from the mother's own bones to supply the baby, leaving her physically depleted and suffering from muscle weakness and fatigue.
That is brutal. But the shield isn't just protecting her bones, right? It's aggressively managing the immune system, too.
Right, which has to perform a highly delicate tightrope walk during pregnancy.
Because the mother's immune system has to, tamp itself down enough so it doesn't attack the fetus, since it's technically 50% foreign DNA.
Exactly.
But it still has to remain alert enough to fight off external infections.
And the regulation of that immune shift is heavily dependent on vitamin D. It promotes the proliferation of T regulatory cells.
Peacekeepers.
Yes, these cells act as the immune system's peacekeepers, preventing an overactive, aggressive immune response against the placental tissue. When a mother is deficient, those peacekeeper cells diminish and systemic inflammation spikes.
And that spike in inflammation is what triggers some of the most terrifying complications in modern obstetrics, right?
Unfortunately, yes.
Because the studies clearly link this inflammatory cascade to significantly higher rates of preeclampsia, which is that life-threatening blood pressure condition driven by endothelial dysfunction in the placenta, as well as gestational diabetes and preterm birth.
If we connect this to the bigger picture, it really explains why the American College of Obstetricians and Gynecologists, or ACOG, advises targeted testing for high-risk women. Right. The literature indicates that the safe daily doses required to maintain this maternal shield often range from 1,000 to 2,000 IU, and sometimes push all the way up to 4,000 IU under specific medical supervision.
So what does this all mean for the average patient? I mean, if the medical protocol to prevent severe inflammation, bone depletion, and preeclampsia can require up to 4,000 IU, but the standard over-the-counter prenatal vitamin only tax 400 IU.
That's a huge gap.
A massive portion of pregnant women are basically walking around completely under-armored. They are relying on a baseline that is biologically incapable of meeting the modern demands of pregnancy.
The baseline is vastly inadequate, and the stakes of that inadequacy double when we look across the placental barrier.
Because protecting the maternal host is really only the first phase.
Exactly. The hormone physically crosses the placenta, entering the fetal bloodstream to act as the architectural blueprint for the developing baby.
See, here's where it gets really interesting to me. When I was analyzing that 2018 study from JAMA Pediatrics in our stack, I realized we often talk about prenatal nutrients as raw materials.
Right, like building blocks.
Yeah, we think of calcium as the drywall and the 2x4s for the baby's skeleton. But vitamin D crossing the placenta operates more like an elite project manager at a construction site.
Oh, I love that analogy.
It doesn't just drop off the drywall. It actively hands out the blueprints for how to wire the building's electrical system.
And by electrical system, you are looking at the neurodevelopmental pathways.
Exactly.
The JAMA Pediatrics research highlights that the hormone acts directly on the fetal brain architecture. It upregulates neurotrophic factors, which are essentially proteins that encourage the growth, survival, and differentiation of developing neurons.
It's actively wiring the brain. I mean, we spend so much time obsessing over omega-3s and folic acid for brain development.
Right, which are important.
They are, but this study proves that higher maternal levels of vitamin D translate to demonstrably better cognitive outcomes in the child. We are talking about enhanced language skills, better spatial processing, and stronger attention spans as those children age.
The cellular differentiation driven by this hormone is profound. It influences the development of the dopamine and serotonin systems in the fetal brain.
Wow.
And the project manager doesn't stop at the nervous system either. It is simultaneously laying the foundation for the child's lifelong immune baseline. Adequate levels in the womb support the structural development of the fetal lungs and modulate the fetal immune cells.
Which the data shows actually lowers the child's future risk of developing asthma, severe allergies, and early respiratory infections.
That's incredible.
It's even tied to the immediate physical metrics of birth, right? Like healthier birth weights, proper skeletal length, and higher APGAR scores, meaning the baby transitions into the world with far more resilience.
The dual action nature of this hormone really cannot be overstated. I mean, it is suppressing maternal inflammation to prevent preterm labor while simultaneously accelerating fetal lung and brain maturation. The synergy is just a masterpiece of evolutionary biology.
But, understanding the sheer power of this hormone brings us to a very practical bottleneck for you, the listener.
Ah,
How do you reliably hit that 30 nanograms per milliliter threshold when our environment is basically working against
right,
us?
that's the big question.
The sources outline 3 biological pathways: diet, sun exposure, and targeted clinical supplementation. Let's start with diet.
Well, diet is consistently the weakest link in this chain, unfortunately. You can source small amounts from fatty fish like wild-caught salmon, egg yolks, and fortified dairy.
Okay.
Some mushrooms synthesized with UV light offer a plant-based source,
Yeah.
but the bioavailability and concentration in these foods are just incredibly low.
Right. You'd have to eat an absurd, medically unadvisable amount of salmon every single day just to hit clinical levels.
Nobody's doing that.
Exactly. And if we look at the second pathway, sun exposure, the general advice is usually, 10 to 30 minutes of midday sun with your arms and face uncovered.
Right.
But as we discussed, if you are in a northern latitude during the winter, the UVB rays aren't penetrating the atmosphere anyway.
This raises an important question about the reality of modern clinical care. Theoretical ancestral models of sun exposure simply do not apply to a modern patient managing the extreme physiological demands of IVF or pregnancy.
It's just not realistic.
The margin of error is non-existent. You cannot rely on winter sunlight and egg yolks to protect against preeclampsia or ensure fetal neurodevelopment. Precision is mandatory.
Which is exactly why the clinical brief from the Berkeley Center in New York emphasizes medical supervision and targeted D3 supplementation.
Yes.
They aren't suggesting you blindly pull some random dosage off a pharmacy shelf. Their protocol relies on analyzing the patient's blood work, factoring in the unique metabolic rate and skin type, and prescribing clinical-grade vitamin D3.
Because D3 absorbs much more efficiently than D2.
Right, exactly. So they use D3 to hit those exact optimal ranges.
It really is the gold standard of integrative reproductive immunology. They treat the 30 nanograms per milliliter mark as a starting line, often aiming higher to ensure the immune-modulating benefits are fully active during the entirety of the gestation.
And the brief notes that accessing this level of precision doesn't require living near a specialized clinic anymore either.
Oh, the telemedicine aspect.
Yeah. They outline their own telemedicine model as an example, offering $100 nationwide phone consults, which you can access through berkeleycenter.com, or by calling 212-685-0985, specifically to help patients dial in these precise hormonal requirements from anywhere.
It's about replacing guesswork with biological certainty. Taking control of this single biomarker is arguably the most biologically profound, highly leveraged intervention a prospective parent can make.
It really seems that way.
It optimizes the immediate environment for conception and builds the resilient infrastructure the child will rely on for decades.
So, as you process the science we unpacked today, realize that vitamin D is not just, a casual addition to your morning routine. It is the master hormone of your reproductive journey.
Absolutely.
It opens the cellular toll booths for your physical strength, it acts as the peacekeeper for your immune system, and it hands out the electrical blueprints for a developing mind. Don't rely on the squirt gun of a standard prenatal. Get your blood tested, demand your exact levels, and take control of your hormonal architecture.
The science demands we treat it with the respect it deserves.
Absolutely. And we want to leave you with a thought to mull over today, something that builds on this huge paradigm shift we've been talking about.
Okay, let's hear it.
Because if this project manager is profoundly shaping early brain development, fine-tuning language skills, and setting the baseline for the immune system while we are still in the womb,
Yeah.
how much of our long-term adult health, our chronic autoimmune diseases, or even our baseline cognitive abilities today were actually programmed by the simple, arbitrary amount of sunshine our mothers absorbed before we were even born?